All right, we're working in Chapter 4, Section 2, which in our learning plans is Learning Plan 2.7. What we're doing today is understanding the geometry of systems of equations. We're going to solve 3 equations in 3 variables by elimination and missing terms, and then find some special systems. If you have 3 variables, x, y, and z, their solution is called an ordered triple, and we write the x-coordinate first, the y-coordinate second, and the z-coordinate last. If you look at their, when you solve them, you can either get 1 point as the solution, or a line as the solution, or all the points as a solution. No points in common if all 3 are parallel planes. And then if they meet, one of them meets transversely, you could have no points in common. Or you could have all 3 of them meeting and have none of them in common. And you could also have 2 different planes and have none of them in common. So it's pretty, there's a lot of different ways that you can have a 3 different equations lining up. But remember that with 2 there were lines that crossed, with 3 there's planes that crossed. I wonder what there would be if you had 4 variables. So we're going to find figures that are 3 planes meet in 1 point, 3 planes meet in a common line, at least 2 of them coincide, or none of them coincide. So let's see how to solve by elimination. In the steps that follow, we use the focus variable to identify the first variable to be eliminated. The focus variable will always be present in the working equation, which will be used twice to eliminate this variable. Okay, so the focus variable, we want to have either 1 or -1 as a coefficient. Eliminate that focus variable, and then we will have 2 equations and 2 variables. In one set of equations, and then 2 variables in the other set. And then when we get 2 equations, we just do those 2 variables, and then check back and make sure we solved our equation. Now, in this case, it appears as though x is going to be our focus variable. And so what we would do is add this equation to each of these 2. So the first and last equations added together give us 3y equals 3. Because if you notice, the z's are also eliminated when we add those 2 together. If we add the second and the third equations together, we get y plus z equals 3. Okay, well, using the first equation, since y is 3, we would have y, or 3y is 3, y is 1. Substitute that into the second equation, z will be 2. And then substituting those 2 into the first equation, we would have x plus 1 plus 2 equals 2. Well, 1 and 2 is 3, so x is -1. Now what you can do is solve this using Excel, and I'll show you how you do that. First of all, open up an Excel spreadsheet. And in that Excel spreadsheet, you would just record the matrix. Actually, there's 4 parts in the matrix you have to record. 1, 1, 1, 2, 1, -1, 2, 2. I'm just doing the coefficients of each one. -1, 2, -1, 1. So you see where each number comes from here. The x, 1 goes there, this one goes here, and so on. This is our matrix. We know that if we have an equation like ax equals b, we solve it by dividing both sides by a, right? Or by multiplying by the inverse. Okay, so all we need to do now is we're going to, in the next box over here, okay, I'm just going to write it down here so that you can see what to do. We're going to highlight all three of these cells, okay, and then we're going to type equals matrix multiplication, M-U-L-T, parentheses. What are we going to multiply? We're going to multiply the matrix inverse of this part right here, which I'm going to highlight so that you can see what we're talking about, which I believe will be cells, I think it'll be cells A1 to C3. Okay. And then, close parentheses. So we're going to matrix multiply that by these right here, which are D1 to D3, close parentheses, and then make sure you press Control, Shift, and Enter at the same time. And then when you press Control, Shift, Enter, this box should say -1, 1, 2. Okay, so if you notice in this example, oops, I guess I didn't do this one yet, but why don't you solve this system of linear inequalities, and then I'll show you how to do it in Excel. Although I can't get Excel open right now, but as soon as I'm done here, I'll make one for you. All right, next. All right, so we are showing how to solve systems of equations using Excel. So what you want to do is you want to go to the cells, and if you notice, I'm going to press 1, -1, 2, 1. So you can see that the 1 comes from this one down here and so on. 3, 2, 7, 8. Last equation, -3x, -4y, 9z, and the answer is -10. So now, over in the slot next to it, you can see the answers are already there, but I'm going to show you how to fill them in. I'm going to, in those cells, I'm going to type equals matrix multiplication, M-U-L-T, parentheses. My first thing that I'm going to do is press the inverse, M inverse, so matrix inverse of A1 to C3, close parentheses, and then my other array is going to be D1 to D3. And I'm going to press Control, Shift, Enter, and those three values, 2, 1, 0, come up as the solution for this matrix. Okay, so now you try this number here. Okay, so here's, if you notice, I don't even have to press the, I don't even have to type the equation over again because it automatically stays in there. So I just need to press the different values for each of the three different equations. And when I get done, my answer automatically appears. And if you notice it says 1, 2, 4, which is letter A. So now you look. All right. So if you have 3 equations and 3 variables, sometimes you will have missing terms. Notice no letter appears in all 3 of them. If that's true, then when you go to solving the system, you're going to have some problems. Let's see, what can we do? Well, if we substitute x equals 6 plus y from the first equation and put that into the third equation, we'll have 3 parentheses 6 plus y minus 4z equals 8, or 18 plus 3y minus 4z equals 8. Subtract 18 from both sides, and we will have 3y minus 4z equals negative 10. Now we can use that in connection with the second equation. Let's see, what should we do? Let's multiply the second equation by 4 and this new third equation by 5. When we do, we'll get 8y plus 20z equals 4, and 15y minus 20z equals negative 50. Add these two together, this cancels, and we get 23y equals negative 46. So y equals negative 2. So if y is negative 2, 6 minus 2 is x, so x is 4. We could also put y into this second equation. 2 times negative 2 plus 5z equals 1. 2 times negative 2 is negative 4, plus 5 times z equals 1. Add 4 to both sides, so this becomes 5. 5z is 5, so z is 1. Now you can put that into the, look at this one. You try it, exercise 3. Notice the y is missing in the first equation. The x is missing in the second equation, so I just put in zeros for each of those values. And the z is missing for the third equation. And when I get done, my solution matrix is negative 2, 1, 4. Okay, try this one. Okay, here's how I solved it. 0 for for z. Second equation, x is 0, y is 2, z is 1. Answer is 17. Third equation, x is 1, y is 0, z is 4. Solution is 22. Oh, I might have done something wrong. 3, negative 1, this is supposed to be. So if you make a mistake, you can correct your mistakes pretty easily. And you see the answer is B. Matrix also, you solve this one. Alright, if we try to solve this equation, notice It's pretty tough to come up with a focus variable. I think z would be the easiest one to focus on. Let's multiply the the middle equation by 2 and add it to the top equation. So the middle equation times 2 is 10x plus 16y minus 2z equals 8. Add it to the top equation. 13x plus 11y equals 9. And then multiply it by negative 4 and add it to this last equation. So by negative 4, it becomes negative 20x minus 32y plus 4z equals negative 16. Add that to the third equation. You have negative 26x minus 22y equals, let's see, 21. What does that equal? It's negative 16 plus 5 is negative 11. All right, if you notice, these two equations have the same slope, 13 over 11 negative, and 26 over 22 negative, which this simplifies down to the same thing. Since they have the same slope and different intercepts, those two are parallel. And so this would be one of those cases where you have two of the equations are parallel. And so the third one, if it does cut across it, is only going to result in two lines that don't intersect. And so we would say these are an inconsistent system. All right, for this one, let's see what happens when you try to solve this. 1, negative 5, 2, 4, 3, 1, negative 1, 6, negative 2, 10, negative 4, 7. If you notice, as soon as we, at some point here, I think it was right here, huh? Yeah, as soon as we got negative 4 here, then our answer matrix came up number, and so that means there is no solution. The system is inconsistent, we would say. Try this one. Oops. Okay, so we enter, oops, 2, 4, 6, 51, 1, 2, 3, negative 17. And if you notice, as soon as we had 2, 4, 6, and 1, 2, 3, it was an inconsistent system. So it doesn't matter what this third one is, it's going to be inconsistent because those first two are the same. And so we would say it's an inconsistent system. There is no solution. All right. Now, if you notice here, you've got kind of the same thing going here. Let's multiply the top equation by 3, and we get 3x minus 3y plus 3z equals 12. Add that to the second equation, you get 0 plus 0 plus 0 equals 0. So those two equations form the exact same plane, and so you're not going to be able to get anything out of that one. And in fact, if you double the first one and make it negative, so it'd be negative 2x plus 2y plus 2z, no, I'm sorry, minus 2z equals negative 8, and added to the last equation, you would have 0 plus 0 plus 0 equals 0, and so actually all three of these have the same system. All right, if you run into situations like this where you have fractions, one way to do it would be to multiply everything by the common denominator, and this second equation would become 2x plus 3y minus z equals 8, which, if you notice, is the exact same as the first equation. And then multiply the last equation by 2, the common denominator, and you get 2x plus 3y minus z equals negative 12. And those two would then form parallel planes. These two equations are the same plane. This one is a plane parallel to those two. Oops. Try this one. One, negative 3, 2, 10, negative 2, 6, negative 4, negative 20, and 0.5, negative 1.5, 1, 5. If you notice, it again says there is no answer matrix, but the difference is this time they are all three the same equation, and you can't even tell that from the way that Excel did the worksheets. So this one, you wouldn't know that there are multiple solutions to that one, unless you had done it by hand, I guess you would say. Okay, let's try this one. 1, negative 3, 2, 4. I'm going to multiply the middle equation by 3 so that I suppose I could do equals 1 slash 3 in that first one. Negative 1 equals 2 slash 3 for that one. 7. And then 0.5, negative 1.5, 1, 2. Regardless, you still get no solution for this one. And I believe that's all of them. So if you have any questions, you can give me a buzz. Otherwise, I'll see you next time. Bye now.